Hey, good morning, everyone. Today, we keep working on some conceptual contents, especially having some further background knowledge about the Hadoop ecosystem. But before that, let me go over through installation of Spark, because I guess you need it for the next classes. And in the previous class, I just briefly went through the Spark. So let me just keep working on the content. But before that, I mean, on top of the door closure, it seems to have another technical issue here. Just a moment with me. So let me pause the video for a second. Okay, so about the Spark installation, I mean, in the next class, I'll go over the overview of the installation. There is so many online sources for you guys to understand the steps that you need to follow. What I install is the latest version of Spark. When you go with some tutorial, the old version, I mean, especially Spark 2, we are going to work on Spark 3, and because there's some some methods that people used to work in Spark 2 are getting obsolete, like RDDs. So when you want to work over RDDs, they are not. I mean, Apache doesn't maintain those methodologies over Spark 3, so they're getting obsolete. Which is actually not a bad thing. I mean, RDDs are not that much convenient to work with, especially if you just start learning Spark. So having said that, select the latest version, Spark 3. If you've already installed Spark 2.4, it shouldn't be a big issue. Actually, the main advantage of Spark, there is another advantage of Spark 3, which are, I mean, there is more tools for deep learning, and you have more tools to work with the visual graphic cards. But we don't go that much. We don't have that much of time. So if you already installed the second version of Apache Spark, shouldn't be a big issue. But if you haven't, go to Spark 3. And in the second part, you see that there is actually Spark is a programming tool over Hadoop. So for the second part, you have different instances of Hadoop, 2.7, 3.2, and pre-built with user-provided Apache Hadoop. I select the last one because I already installed Hadoop, so I can install Apache Spark over Hadoop. But if you haven't installed Hadoop, you need to select either first two options, either Hadoop 2.7 or 3.2. And you need to, if you look at the online tutorials, if you select the first two options, you need to download WinUtils. WinUtils is basically a file that, I mean, you use it in Windows, and basically it works as a instance of Hadoop over your system. So if you if you already install Hadoop, you don't have to install WinUtils. And I think these are the big differences. The rest is, you can follow the tutorials. But keep in mind, these are community-based softwares. What I mean community-based, there's not a commercial, it's not a commercial tool, and there is no private or public institution supporting them. They don't charge you. So you might face some errors and bugs, which you need to ask from community. So having said that, for example, you go to Stack Overflow. And you ask a question. You type your question and other people helps you and try to answer your question. It's similar to our GroupMe, but in an international scale. It might take some time, and there is no guarantee that people solve your questions, but usually it happens. Usually people answer your questions very well. I never had any experience that I have an open question. Every time that I post a question, somebody helped me. And if they help you, I think they give some score and some ratings. It might, I'm not sure what's the advantage of that, but I know people get some scores by rating you guys. It's like your attendance credit that we have grouping, but in the Stack Overflow scale. You can use it for many things. You can post your statistics question. I think that name is Stat Overflow probably, or Python, or any programming problems that you have. You can ask over Stack Overflow, and people try to help you. For example, you see a sample question: is the R function finding the index of an element in a vector? So it's just a sample question. You can put a title for your question. Just a short title, just generate talking about what you are asking. And in the body, you can put the details of your question. Even you can take pictures and put it here. Okay, any questions from previous class or this class so far? Oh, one thing. Many of you asked almost same question. Please post over GroupMe. Your question might be similar. For doing your assignment, you need, you need to connect to the Hadoop environment, the virtual environment. But first, you need to run the virtual box. Then if you are using Windows, use PuTTY. Otherwise, in the Mac or Linux, you need to run terminal. So if you don't run VirtualBox, you cannot use PuTTY or terminal to connect to that virtual server or your local host address. So I've seen that many of you had a very similar question. If you ask over GroupMe, or maybe you can ask even a Stack Overflow, people can answer your question, and probably there's so many similar questions. In some cases, when I put my question in a Stack Overflow has a algorithm that shows me somebody already had the question and they show me the answer. So actually it's really, really good tool. So if there is no question, just let me go to the Hadoop ecosystem. Today's class might be a little boring because we go over some concepts, but first of all, you need to know those concepts. Second, we had multiple lab sessions, and I know you guys might be busy with installations and your assignments. So let's have an easy session today. So, and from next week, again, we're back to the coding and hands-on experiences. Okay, so we already talked about Hadoop ecosystem. The core part of Hadoop is the distributed file system, Hbase NoSQL database, which is a new structure of databases, and Hadoop Yarn. If you remember, when we wanted to install Hadoop, it was a command at the end of lecture that I put start-yarn, and you run your Yarn framework. Basically, it's a stand for yet another resource negotiator. It just manage all the resources that you have on system, how many nodes you have, how to distribute your files and data over your system. So on top of the Hadoop core, we need to have some tools that makes our life easier. So you don't want to code everything from scratch. Hadoop ecosystem, basically the core was designed by Java and Scala. Especially Java is the core of the Hadoop ecosystem or Hadoop core. So you don't have to use other tools, and you can directly work with the Hadoop, but it's much more difficult. So there is so many other tools that develop to make your life easier. For example, we have Pig and Hive. It's kind of some programming that you use for mostly like managing your databases. Spark, which is the programming platform, and over Spark we have PySpark and RSpark. In PySpark, you do Python programming over Hadoop ecosystem. RSpark uses R programming for, doing your task over Hadoop ecosystem. There is when we go to the Python part, you see that you basically call some packages, and over those packages you can submit your Python codes and get the results back. Otherwise, same as the previous classes, you remember we had some MapReduce commands. You need to be that much details. So you need to basically run a mapper, send your codes, then use a reducer, get the result back. And that was for a really easy example. Just keep in mind, if you have a very big program, working directly with Hadoop is actually difficult. So also, the core database of Hadoop is not SQL based. The structure is different. And today, we basically talk about Hbase NoSQL database. People use different platforms like Flume and Scoop to just import and export data from other conventional databases like SQL Server, even Access, to send them to Hadoop and return it back. And today, we go over the big differences of Hbase system and like SQL-based database systems. So as you see, people use different animals. So there is a actually interesting platform. They call it Zookeeper. Basically, they take care of all of the nodes, all of the program, and all the databases that you have. For example, if suddenly one of your nodes or cluster got broken, or some of them suddenly turn off, it first try to restart that node. Otherwise, redistribute the work between different nodes. So you might remember that in the first class, we talked about why should we have parallel processing, why we should have multiple nodes. And the reason was we want to improve the tolerance of our system. But managing those nodes is challenging. And Zookeeper basically just manage all the platforms and infrastructure that are under Hadoop ecosystem. So if there's any problem, Zookeeper is for just taking care of that. Any questions? So if there's no question, let me just show you a code in PySpark. Basically, I'm showing you an example of a Spark, PySpark, Python in a Spark. On top of simple programming, you need in a PySpark or Spark, you can work with a stream of data. So you might remember in the analytics programming, the data was already downloaded and you work over like a data set. But when you have a stream of data like tweets, YouTube videos, Facebook comments, the stream of data is coming every second, a new data is created. One of the advantages of Spark is you can do analysis over a stream of data. You don't have to download them somewhere and do analysis later. You can have online analysis using Spark. So let me show you a sample code that I already put in on your model for week 3. So just let me see if I can make it larger. Yeah, this is a really simple IDE. I'm not sure if you can see what I'm doing. So as you see, we import PySpark package in Python, import the code, and basically in the next class I explain them, but as you see, we bring the u.data here. Also, at the end, we look at ratings and bring the histogram of ratings. So let me just run it. So here, I just type Spark dash submit. I already installed Spark on my system. So it's the reason after you install Spark successfully, you can run this code. So Spark submit. Then let me put the address of that file, c-spark codes. So I just put the Spark submit and the address of code on my system. So if you download on your system, your address might be different. So instead of c/spark codes ratings spark py, you might put a different address. Just taking time. I get some warning, but it still is, the code is running. I have so many things running on my system, so my system is actually slow to that this time. But just if you wait, anyway, my system is slow at this time. But you look at the previous run, I said Spark submit the code address, and you see the distribution of stars, like 1 star, how many, 2 star, 3, 4, 5. In previous class, we run a MapReduce over Hadoop, so yeah, the result is exactly the same. Again, I'm running so many programs on my system, so it's the reason it's very slow. I'm not sure how long it might take, but if you install successfully, you should get these numbers like 611, 1137, and 5 star should be 21, 203. Let me just open the code again. So also after you download it, within your Python code, you need to change the address of, let me share it with your friends. So after you download, install Spark successfully, and after you download this Python code from your Moodle, you also need to put the address of u.data here. So the part that I'm highlighted has your u.data address. So again, you need to update 2 things. One, within the Python code, you need to update your address of u.data here. Also, in the command prompt, which is still running, and maybe I need to restart it. So when you for submitting your code, you should type Spark -submit, and as you see, comma, Spark codes rating spark.py. Basically, Spark codes rating spark.py is the address of my file. So on your system, this part also might be different, but you have to type a Spark submit. So two updates. First, the address of your Python code here. Second, address of u.data here. So on your system, these two highlighted parts might be different. Anyway, this is just for testing your successful installation of Spark. Again, you might get some warning, but no worries. I mean, also in the next class, I show you how to turn off some of those messages. But you might get so many warnings, but that shouldn't be a problem. So in this course, we mostly focus on, we already had some understanding about MapReduce and how to run MapReduce directly. Also, we have some focus on Spark Part 2, but we get familiar with other technologies. So we had some examples. We will have some example of Peak, Hive, and Scoop, these three. Also, we have a focus on Spark. And if you have time, we can go over other sections, but actually it's a really huge content and we cannot just cover everything in just one course. So in a Spark, which is, I mean, as I said, we work with the PySpark, you learn how to run machine learning algorithms and type it over Spark. Any questions? Okay, let's talk about a little bit of Hbase, which is NoSQL database system. NoSQL is basically means the structure of data management is not something similar to SQL Server that you used to. So Hbase basically is highly available and fault tolerant. Again, fault tolerant means you have so many instances of your data over different cluster nodes, and if some of them broke away or break away, so you have other copies, and Hbase can handle with the remaining nodes. So it's very fault tolerant, very scalable. Basically, you can have petabytes of data and even more, and it just brings some good capabilities of handling massive, very large databases. It's an open source, and so Hbase, generally Hadoop is an open-based structure. For working Hadoop, you have two things. There's two approaches. Again, one of them is community-based approach, which we do in this class. So whenever you have problems, you reach me or group me or Stack Overflow. But even although it's an open source platform, there is some companies that provide it for you. So when a company provides for you, any time that you have an issue, they fix it for you. So that your life might be much easier. For some of the companies are like Cloudera, which we got Horton Sandbox from them. Also, Amazon, AWS, Google, all of them provide infrastructure for Hadoop and parallel processing. In those companies, you should pay a charge. So they charge you for helping your issue. So they already have very skillful programmers that they handle any issues that you might face over their Hadoop ecosystem. For instance, if you have some Hadoop issues in Amazon AWS, you can ask from Amazon directly, and they fix it for you. But when you work by yourself, you might have some difficulties, especially, and you might face so many errors, which is very natural because you're working with the community-based version of the platform. So the advantage of Hbase, very fast in hand for and random access you can consider as a fast access, and they can easily handle big large data set, and tables are defined. Columns in Hbase tables defined dynamically. So basically, the unit of tables are the unit of tables is based on the column family. As you see, one of the example of Hbase capacity, look at this one, storing the entire internet. So if you have, it gives you some enough programming platform that you can just record everything on the internet. Maybe you don't need that, or you shouldn't, but you have that much of capabilities. And you can run thousands of operations per second, like Facebook messages. Facebook is over Hadoop ecosystem. They have 75 billion operation per day. In the peak, they have 1 million operation per second. And all of the Facebook data sets is managed over Hbase NoSQL data set. So how they manage the scalability? They just add more nodes. So Hbase provides a good infrastructure. So whenever, like Facebook, when they grow their company, they just can buy new nodes and just increase the scale of their data set. You can cache your data in the memory, which is a faster recording system, much faster than hard drive. And let's see. So let's see when we need Hbase, when we need random read and writes, thousands of operation per second on multiple terabytes of data, and the pattern is well known and repetitive. So you don't have any new patterns of data recording and calling. So when we don't use Hbase, many cases that you need like many advanced analytics work, and you don't have to just record your data on the several nodes. Maybe you can make a large node, and if your data is not that much big that one large node can handle it, what's the point of using Hbase? Basically, SQL is much faster. In my point of view, SQL is much faster than Hbase. Hbase is still fast, but for simple analytics programming, it's not the best option for you. Look at the example of enterprises that work with the Hbase: eBay, Facebook, FINRA, Pinterest, Salesforce, StumbleUpon, Twitter, Yahoo. And that link, you can see further examples. As you see, the companies that have a very large data set and customers or clients, such as Twitter, Yahoo, Facebook, eBay, all of them put their data over Hbase NoSQL database. Okay, let's look at the different use case characteristics. For messaging, examples are Facebook, Telco, Tumblr, Pinterest, Pinterest, Pinterest. So characteristic, they can handle random read and writes, reading of top end entries. Simple entities are like such as geolocations data and search index building, and graph data, metrics. And these are, I mean, messages might be more well-known examples for you. So in graph data, it could be network traffic, financial transaction, and click streams. Metrics, campaign impressions, click counts, and sensor data. So these are some missing features from Hbase. Basically, we use other platforms to help us with these missing features. But basically, integration with the SQL is very hard to, Hbase cannot interact very well. So we use other platforms such as Hive, Impala, and to have interaction with the SQL or RDBMS databases. Support for transactions are low. It cannot provide multiple indexes on a table. You just have one index versus if you know in the simple RMDBS. Again, RDBMS stands for Relational Database Management System. You might have multiple indexes or multiple unique columns. It doesn't provide ACID, which is atomicity, consistency, isolation, and durability characteristic, which you probably have seen in your SQL course, so I don't go there. So let's summarize what we have reviewed so far. So, the main reason that we use Hbase database is when we have a very large data set, we face some technological limitations, which Hbase deal with that and help us. So it's the reason we go to Hbase when you have big, large data set. Core components of Hadoop are HDFS, Hadoop distribution, Hadoop file system, and MapReduce methodology. Hbase is a NoSQL database that runs on top of HDFS. These are the traditional database, relational database management system. And it allows for large tables and high throughputs. Basically, as a summary, Hbase just can handle large set of data set, which is not possible to handle with the SQL based data systems. So let's look at some definition in the Hbase, which is similar to HDFS concept that we had. Node is a single computer or single computation. Cluster, a group of nodes connected and coordinated by certain node to perform tasks. Master node, a node performing coordination task. Worker node, a node performing tasks assigned to it by a master node. Daemon, a process or program that runs in the background. So you might remember when we install Hadoop and you type the command of start/yarn, you see that there is something saying that this daemon or that daemon is working in the background. So although similar to traditional RDBMS tables that we encompass your data. Data in Hbase is also recorded in tables, but it is split to HDFS blocks and stored on multiple nodes in the cluster. So you have multiple copies of your data. Hbase, one of the interesting things in Hbase, on top of row and column, you have a column family. Let's say you have a family of your identification, that it could be your name, first name, father name, mother name, and your characters. You might have a family of address family, maybe your state address, country, or your block number. So basically you divide your columns into families, or you cluster them over families. For each row, we have a row key to look it up, and columns hold data for the tables. Sorry, I know it could be boring today, but we need to have at least a grasp on this general idea behind the Hbase. So the computation is distributed, which means multiple machines are working on the same data at the same time. These are the family names. I just recommend to go over, just skim through them. I just need you guys to have some general idea about the Hbase structure. I don't evaluate you for your, to memorize them, but just go through them and see how they works. This is one example of column families. So we have a family of contact info that has first name and last name. We have a row key that identifies each row. These are unique names. And we have profile photo that is a new family. So one family should have at least one column. There's a limitation in the cell size, shouldn't be more than 10 megabytes. Okay, so how the commands, which commands we have? So we have generally 3 or 4 types of commands in Hbase. Get command gives you one row, scan brings all the rows. So basically in the scan you identify beginning or start key and end key, and it brings all the rows within those commands. You also have a delete command, which remove a row key. Okay, let's have a general comparison between RDBMS, which is traditional SQL-based databases. You already had the general knowledge about that, and Hbase NoSQL database. So in RDBMS, data layout is in row and columns, but in Hbase we have a column family. Transactions, these transactions are supported in RDBMS, but in Hbase we just have single row at each time. Query in the SQL is in RDBMS is very advanced. You can do so many. You already know that we have very advanced command in the SQL-based databases, but in Hbase there is just 3 commands. So basically, just as a very quick differentiation, Hbase is just for handling a massive amount of data that you just have it for piling it. You just read, you just put the data, read the data, or at most scan and delete them. So the query is very simple because basically you don't do that much of advanced interactions with your data. You just pile them up somewhere. But in SQL databases, you have so many types of query that you can do. So again, RDBMS is very good for smaller size databases that you basically mostly for your general analytics, you work with the SQL, but when you want to work with a massive amount of data, your query is not that much complicated, but the good thing, it can handle large amount of data. As you see, max size of the RDBMS is just terabytes, but Hbase is even more than probytes of data. So in RDBMS, you can do thousands of operation per second, but in Hbase, you can do millions or billions of transactions. The reason you have multiple clusters and work at the same time, so basically each of them do thousands of operations, so together they can run millions of operations per second. Let me just go skim through them. Hbase shell. Here I put some sample Hbase shell codes. Basically, you see some sample of get command, which basically you identify the column key or the key of the row from the column key, and you get your data. Create, drop. Just let me go over them, skim through them. I mean, at the end, we use a bit more advanced platforms. We work with the Scoop and Hive, which is more advanced them. So I'm not that much picky. If you have time, you can go over the Hbase command, but again, it's not the core of this course. So here I put some general description of get and put command. So, and these are like with the get, basically you get a single row. With the put, you put your data in your Hbase SQL database. As you see, there's some examples here. In a scan, you need to identify first and last row, row keys, and it just brings all the data to you. Anyway, I mean, just for your delete data. Yeah, I mean, let's just stop by here because, I mean, we can talk about the Hbase commands, but again, it's not what you use in this course. Usually, if you work as a system, if you work in the Amazon that you need to support background of Hadoop ecosystem, you need to know them, but it's not the point that we focus that much on the commands and how differentiate and those kind of things. So for the remainder of the class, I'm here to ask to help your issues that you had either with your assignment or installations. But if you don't have any questions, that's it for today. Again, sorry, I know it was very boring, just go over some definitions, but you know, you need to get some general idea about Hadoop ecosystem, Hbase, so on and so forth. In some next classes, we review some other concepts. For example, we go over Spark, Hive. We will have some Hive and Peak experiments working with the databases. And again, from at least half of the semester would be over Spark, so you will run so many Python codes and run some machine learning algorithm using this ecosystem. When we go to Amazon, your life might be much easier because the Amazon Hadoop ecosystem is paid. You can use a free, I think they give you a $100 credit, but if you end up working in the institution that working with the like a paid version of a Hadoop ecosystem, your life might be much easier, and you probably you face less issues in comparison with your own installation. Okay, let me pause the video and then I start from, let's see.